This video has been produced as a guide to assist site managers and employees to modify, develop, document and implement their own lockout isolation procedures. Everyone in the workplace has a responsibility for their own health and safety and that of others. The information presented in this video explains what is required to design a good lockout isolation procedure and uses step-by-step demonstrations. There are a number of good examples of lockout isolations used in the industry, and these form the basis of this video. A good lockout isolation procedure carried out correctly will help prevent injuries and save lives. Everyone has a responsibility for their own health and safety and that of others, and must abide by the occupational health and safety laws and regulations governing their workplace. It is the responsibility of the employer whose employees are engaged in repairing, installing, constructing, erecting, adjusting, inspecting, operating or maintaining the plant and process to develop, document and implement safe systems of work. Safe systems of work include policy and procedures for isolations, lockout or isolation devices, danger tags, permit to work systems, other control measures. An isolation is the act of safely isolating plant from energy sources, thus preventing uncontrolled releases of energy, and includes locking the plant in a safe position. Isolation procedures are a critical part of the operation at a mine and quarry, and are commonly used in association with maintenance and repairs on fixed and mobile plant. The aim of isolations is to prevent people from getting injured and plant from getting damaged while work is carried out on the plant. A good lockout isolation procedure ensures that plant is unable to be turned on while an employee is working on it. An energy isolation point is the physical point where plant is safely isolated from energy sources. All energy isolation points should be uniquely and permanently labelled to indicate their function for isolation purposes. Energy can be in many forms and comes from numerous sources, including thermal, chemical, pneumatic, hydraulic, mechanical, electrical, gravitational, radiation, and radiant. It's important that stored or residual energy be dissipated or restrained. This may include restraining a truck tray or lowering a bucket to the ground. It is important that a hazard safety analysis be performed to identify all energy sources and related exposures before any work commences on the plant. The major components of a lockout isolation are that the procedure is planned and isolations are locked, verified, and carried out by appropriately trained authorized personnel. While specific procedures may vary from site to site, the essential steps exist in all procedures. A good lockout isolation procedure requires that all isolations and maintenance stops be planned. Prior to any isolations being started, all parties involved in the isolation must meet, document and sign off on the isolation. Information discussed in the planning process includes the plant to be isolated, hazard safety analysis requirements for the work, who is responsible for the isolation, a list of associated tasks, the sequence and the people involved, what type of isolation procedure to be used, the authorized person to isolate the equipment, This information is distributed to all people involved in the planned isolation of the plant. It is critical that everyone on site receives the necessary isolation procedure training. It is an employer's responsibility to ensure that all employees and contractors fully understand and comply with their role in the site lockout isolation procedure. Different roles require different levels of training. There are a number of people involved in an isolation, each with designated roles that require specific knowledge and skills. On some sites, one person may be able to perform several roles. The responsible manager is the person responsible for the planning, direction and control of workers' safety within a recognised production area. An isolation planner is the person who plans and documents plant-specific isolation procedures. Isolating planners must be aware of the skills and qualifications needed by an isolating person, like the ability to isolate a radioactive energy isolation point or an electrical energy isolation point. Isolation planners must have knowledge of all energy sources associated with the equipment. Ensure hazard safety analysis is conducted to determine isolation requirements. Identify the relevant energy isolation points. Identify the method of locking energy isolation points. And ensure that all necessary requirements are included in the isolation permit. The isolating person is the only person authorised to safely isolate plant by applying specific isolation locks to energy isolation points. The isolating person must have good knowledge of the area and associated hazards, completely understand the plant that they are isolating, be able to identify all the energy isolation points for the plant, carry out isolations according to lockout isolation procedures, ensure workers know where to place their personal danger locks, have a good understanding of the limits of the isolation. Before employees and contractors start work on isolated plant, they must be trained in the site's lockout isolation procedure. Employees and contractors working on isolated plant must attach their personal locks at the required points for personal protection. An authorised employee should perform a periodic review of the lockout isolation procedure at intervals to be confident that the isolation practices comply with site requirements.